My dear students, hello everybody. Today we are going to study a new lesson, which is introduction of complex numbers and adding, subtracting, multiplying these numbers. Stand by with me and get your mobile away and concentrate. Okay, let's go to the first presentation here. It's introduction, complex numbers, adding, subtracting, multiplying, and dividing complex numbers. Okay, we know that complex numbers contains all these numbers: natural, whole numbers, integers, rational, real numbers, and irrational numbers. Okay, complex numbers are written in the form of a plus bi, where a is the real part and b is the imaginary part. A plus bi. Yes, a is a real number, b is an imaginary number or part, and when adding complex numbers, add the real parts together and add the imaginary parts together. So if we have this number 3 plus 7i plus 8 plus 11i, we will add 3 with 8. Why? Because they are the real parts or real numbers. Yes, and we add 7 with 11. Why? Because they are imaginary parts. So the answer will be 11 plus 18i. We add 3 plus 8 first equals 11, then 7 plus 11 equals 18. Let's go to the second one. When subtracting complex numbers, be sure to distribute the subtraction sign, then add like parts. We have here 5 plus 10i minus 15 minus 2i. We have to multiply negative by 15 equals negative 15, and negative multiplied by negative 2i equals positive 2i. And we will add 5 as a real number plus negative 15 as the second real number. The answer will be negative 10. Okay, then we will add the imaginary number, which is 10i plus 2i. The answer will be 12i. Okay, when multiplying complex numbers, use the distribution property and simplify. We have here, my dear students, 3 minus 8i in a bracket, and the other bracket is 5 plus 7i. We have now two brackets multiplied by each other. So concentrate with me. We will find that 3 times 5 equals 15 here, and 3 times 7i equals 21i. Then we transfer to negative 8i. We will multiply negative 8i by 5. The result will be negative 40i. And we multiply negative 8i by 7i. The result will be negative 56i power 2. Okay, remember, my dear students, that I power 2 from the definition of the imaginary number equals negative 1. And we will add the real numbers with each other. You have 15 here, and 15 has no other like term. Here we have 21i, negative 40i, negative 56i power 2, but we have 15i. We have just 15. Because of that, 15 will still as it is. Add 21i with what? With negative 40i. The answer will be negative 19i. And remember that I power 2 equals negative 1. If we multiply negative 1 by negative 1 by negative 56, the answer will be positive 56. The excellent student look forward to 15 and 56. Now they are like terms. 15 plus 56 will add it together. The answer will be 71. And negative 19i has no like term with it, so it is remain as it is, negative 19i. This is the answer. To divide complex numbers, multiply the numerator and denominator by the complex conjugate of the complex number in the denominator of the fraction. Look carefully. We have now divided by 7 plus 2i divided by 3 minus 5i. We would like to simplify this part of a question. Now we will multiply numerator and denominator by what? By the conjugate of 3 minus 5i. What is the conjugate of 3 minus 5i? We mentioned that in the first episode, my dear students, that the conjugate of 3 minus 5i is 3 plus. We convert this sign, 3 plus 5i. Okay, the complex conjugate will be 3 plus 5i. Now we will start to multiply denominator and numerator by the same number, which is 3 plus 5i. The answer will be that. Why? Look with me and concentrate. We will multiply 7 by 3 first, equal 21. 7 multiplied by 5i equals 35i. 2i multiplied by 3 equals 6i. 2i multiplied 5i equals 10i power 2. And that don't forget that the I power 2 equals negative 1. Okay. The denominator, we will multiply 3 by 3 equals 9. 3 multiplied by 5i equals 15i. And start with negative 5i multiplied by 3 equals negative 15i. Negative 5i multiplied by 5i equals negative 1525i power 2. We will simplify this expression. Numerator first, we have 21 still as it is because we have no like term with it. 35i plus 6i equals 41i. And don't forget that I power 2 equals negative 1. So negative 1 times 10 equals negative 10. And we have the denominator. 9 has no like term with it. Well, still as it is here. And we have 15i minus 15i. The answer will be 0 here. And still negative 25i power 2. I power 2 will be negative 1 multiplied by negative 25. The answer will be positive 25. Okay. We have the final answer. We have here 21 as a real number minus 10 as another real number. The answer will be 11. And 41 still as it is because has no like term with it. 41i. Denominator, we have two real numbers. 9 plus 25 will be equals 34. Try this. My dear students, we will try these questions with each other using papers. So look with me. We have the first question with it, which is 3 plus 5i minus 11 plus minus 9i. Look carefully. This expression equal 3 plus 5i as it is. We multiply negative negative 11, and negative times negative equals positive. So the answer will be negative 11. Negative times negative equals positive 9i. Look with me carefully. We have now real numbers. We have 3. We will add it with negative 11. The answer will be negative 8. And we have the imaginary numbers. 5i plus 9i. And the answer will be 14i. Okay? Look forward. Yes, this is the number 1. We can go to the number 2. We have 5 minus 6i in a bracket multiplied by 2 plus 7i. We have here 2 brackets. We will multiply 5 first. 5 times 2 equals 10, and 5 multiplied 7i equals 35i. And then we will transfer to negative 6i. Negative 6i multiplied by 2 equals negative 12i, and negative 6i times 7i equals negative 42i power 2. Okay, we will add the real numbers. We have 10 here, and we have 35 minus 12 equals positive. 5 minus 2 equals 3. 3 minus 1 equals 2i. And we have also negative 42 multiplied by I power 2, which is equal what? Yes, negative 1. So the answer will be here equals 10 plus 23i plus 42. The final answer will be 52 plus 23i. Okay. Now we will go to second question, and it is division. So look concentrately with me. Yes, look here. We have number 3, 2 minus 3i multiplied by or divided by 5 plus 8i. We said that when we have a division like that, we have numerator and denominator. We multiply numerator and denominator by the conjugate of the denominator. 5 plus 8i is the denominator here. Try to find out the conjugate of 5 plus 8i. The conjugate will be 5 minus 8i. And we must multiply the denominator and numerator by the same number, which is 5 minus 8i. Yes, we have here a long fraction. We have 2 brackets multiply each other here, and we have the 2 brackets in the denominator multiply each other here. And look at the answer. 2 multiplied by 5 equals 10, and 2 multiplied by negative 8 equals negative 16i. So then we start with negative 3i. Negative 3i multiplied by 5 equals negative 15i. and negative 3i multiplied negative 8i will be positive 24i power 2. And we have these two numbers here. 5 multiplied 5 equals 25, and negative 8 times 8 equals 64 I power 2. Why we not try 5 times negative I, 8i, and 8 times 8i times 5? Because the sum will be 0. Because they are difference of two squares. 5 plus 8i multiplied by 5 minus 8i are two perfect square, or different two squares. So the middle part will be 0. Okay, we will go to simplify. 10 will start, yes, and negative 16 plus negative 15 here equals negative 31i plus 24 times I power 2, 24 times negative 1 will be negative 24, and we have 25 minus 64 multiplied by negative 1. Okay, the final answer here will be equal negative 14 minus 31i over 89, and it will be the final answer here. It's very easy to calculate. Okay, my dear students, now we are going to the next question, which is easier. We will add two brackets here. Look carefully. 19 minus I plus 4 plus 15i equals, we add 19 plus 4, the answer will be 23, and we add negative I with positive 15i, the answer will be 14i. It's very easy to you, and you can check using your calculator. Now we are going to the next slide. We have here what is a set of real numbers. Yes, imaginary number were invented. Why invented the imaginary numbers? The negative numbers would have square roots, and certain equations would have solutions. And we have I power 2 here equals negative 1. Remember that. Okay. We have here the I power 1 equals I power 2 equals negative I, and I power 3 equals negative I power 4 equals 1. Okay, we have here I power 4 equals 1, I power 3 equals negative I, and I power 2 equals negative 1. Now we will start to investigate about some numbers of I. I know that it's a problem for some students, but for you intelligent students it's very easy. So watch with me. We have here I power 23 equals what? I power 23, it's an odd number. Okay, try to get out all fours, because we have here I power 4 equals 1. This I power 24 equals I power 20 multiplied by I power 3. Okay, I power 20 means I power 4 times I power 4 times I power 4 times I power 4 times I power 4. All of them are ones. These I power 4 is ones. 1 times 1 times 1 times 1 times 1 equals 1. So I power 20 equals 1 multiplied by I power 3, and I power 3 equals I power 2 times I, so it is equals negative I. Okay, and if we have a very large number as I power 2006, I power 2006, we have here 2006. The question is this number divisible by 4? And you can try using your calculator here. If we have 2006 divided by 4 equals what? Equals 501 and a half. Okay, equals 501 and a half. This number equal 501 and a half. Half means equals 2 over 4. So the remainder equal 2. So we can say that all this number equals I power 2, which is negative 1. So the answer will be negative 1. Okay, let's begin with another part, which is the types of roots of the quadratic equation. Okay, after some short we go to a short break and we will return again. Thank you. Hello, my dear students. We are going to study a new lesson, which is third lesson in algebra, which is determining the types of the roots. Types of the roots here. Types of the roots. We have 3 types of the roots. First type will be positive, which is greater than 0. Second type is equals 0. And third type is less than 0 or negative. What's happened to this, the 2 roots? Okay, the 2 roots connected with something called discriminant. What is discriminant? Discriminant is b power 2 minus 4ac equals what? Sometimes this discriminant equals positive number like that, or equals 0 like that, or equals negative like that. Okay, what happened if the discriminant here equal positive number or greater than 0? Then we will predict or guess that the 2 roots will be different real. 2 different real roots. Okay, we'll predict that if the b power 2 minus 4ac equals positive number or greater than 0, the 2 roots will be 2 different real roots. And if the answer of b power 2 minus 4ac equals 0, then we will know that the two roots are equal real roots. And if we have the answer will be less than 0 or negative, then the two roots doesn't belong to R, but we have two different complex roots. C means complex and R means real. Okay, let's see why this. Why discriminant knows us or can make us know that if the two roots are two different real here, or equal real, or doesn't belong to R and complex numbers. Why this happened? Look carefully for me. We know that if we want to solve the quadratic equation like this, x power 2, and we have a here, plus bx plus c equals 0. That is the form of the quadratic equation, and we have the formula. We have the formula which x equal negative b plus or minus square root b power 2 minus 4ac over 2i. This formula, if we applicate it, will be answer the question of find the quadratic equation roots, which is ax power 2 plus bx plus c equals 0. So look carefully and concentrate about this number. If this number equals 0 here, we have positive or negative, negative b over 2a. What happened? We have only one number, which is negative b over 2a. So when discriminant here equals 0, then we have only one number, which is negative b over 2a. This number will be the root of the quadratic equation, which is ax power 2 plus bx plus c equals 0. And we know that if we want to find x equals negative b over 2a, this equation will be the symmetry equation of the curve. If we have a curve here, parabola, the symmetry equation here, if we have x-axis and y-axis, we will have the axis of symmetry. Its equation will be x equals negative b over 2i. And the two roots are equal, and each of them equals this number. So if the discriminant b power 2 minus 4ac equals 0, then x equals just one number. That means that the two roots are equal in measure or equal in magnitude, and x equals this number. It is the axis of symmetry of the parabola. And if we have, my dear students, we have the reason here to why if we b power 2 minus 4ac, which is discriminant, equals 0, the answer or the two roots will be equal and are real. Let's see here another example. We have x equals negative b plus or minus square root b power 2 minus 4ac over 2a. If we have this number, which is b power 2 minus 4ac, discriminant equal positive number. If it is positive, then we have two solutions. Say a heart over 2a, any number here. We have negative b plus this heart over 2a, and negative b minus this heart 2a. Say this number equal m. So the answer will be equals negative b plus or minus m over 2a over or negative b, we have plus here only, and minus m over 2a. So they are two numbers, two real different numbers, okay, belongs to R. But if we have negative number for the discriminant, we will see here, if we have here x equals negative b plus or minus square root b power 2 minus 4ac over 2a, and this number will be negative, square root negative number. If we have this number will be negative, then we have not real roots. Why? Because this number doesn't belong to R. But we invented as a mathematician a number called I power 2, and this part will be negative b plus or minus something multiplied by I, say k over 2a. So the answer will be negative b plus ki over 2i, or equals negative b minus ki over 2a. Okay, so if we have the discriminant equal negative number, it will be complex and not real, and we have two conjugate roots, and they are not real but complex numbers. Let's go to an example here. Yes, if we have f of x equals x power 2 minus 5x plus 6, and this equation equals 0, and we want to find out what's the type of these roots. We just calculate discriminant, which is b power 2 minus 4ac. What is a here? A here is 1, and b is negative 5, and c is equal to 6. And when we substitute here, we put instead of b negative 5 will be negative 5 power 2 minus 4 multiplied by 1, which is a, multiplied by c, which is 6. Okay, equals, we have 25 here minus 24. 25 minus 24 equals 1. Ask yourself, is it positive or negative number? Yes, it is positive number. So what is the type of the two roots? If the discriminant equal positive number, we have two different real roots. If discriminant equal positive number here, then we have two different real roots. Okay, let's go to another question here. Determine the type. Okay, determine the type of the two roots of x power 2 minus 3x plus 5 equals 0. Let's calculate the discriminant. We have b power 2 minus 4ac. We have b equal negative 3 here, will be 9, minus 4 times a equals 1 here, times c equals 5. So the final answer equals negative 11. this number less than 0. And we agreed that if the discriminant here equals negative number, then we haven't real roots, will be two different complex, C means complex, roots. Okay, let's go to another question. Yes, my dear students, we have the types of the two roots. If the two roots of the discriminant is positive, then we have two real roots. And if it is negative, we have two different complex roots. And if it is 0, will be to have two real equal roots. Let's go to another example. If we have here 3x power 2 plus 10x equals 4. Is this equation in its formula? No, because 4 here is the other side. We can transfer it to the left side. It will be equal 3x power 2 plus 10x minus 4 equals 0. And try to calculate discriminant, which is b power 2 minus 4ac, which is equal b power 2 here equals 100 minus 4 multiplied a, which is 3, multiplied c, which is negative 4, and the answer will be 148. What about this number? This number is greater than 0. So, my dear students, try to predict what the types of the two roots. Yes, the types of the two roots are two different real roots. Okay, we now will go through another example. Okay, we have another example here. Determine the two roots of the equation 7x power 2 minus 11x plus 5 equals 0, and find the roots. This equation will find that discriminant b power 2 minus 4ac, b power 2 will be 121 minus 4 times 7 times 5. Mentally here, negative 5 multiplies 4 times 5 equals 20. 20 times 7 equals 140. And this number equals 121 equals negative 9 and 1. So the answer will be negative 19. This number is a negative, so the two roots will be two complex roots, and they will be what? We have here discriminant equal negative 19. What is discriminant? It's b power 2 minus 4ac. So x equals negative b, which is 11 plus or minus square root negative 19 over 2a, which is 14. So here we have two roots, and the negative 19 inside the root equals what? We have 11 plus or minus 19 root 19 I. We know that negative 1 inside the root will be I over 14. So we have two conjugate complex roots here. One of them positive and the other is negative. And what's the meaning of conjugate? conjugate, that means if we have a root equal to I, then the other root will be negative 2I. Let's move to another example here. Determine the two roots of the equation 4x multiplied by x minus 1 minus 5 equals 0. Is this equation in its formula? Yes, it's no, because 4x must multiplied by x, and 4x also must multiplied by negative 1, and try to simplify this equation. 4x multiplied by x equals 4x power 2, and negative 4 multiplied by 1 equals negative 4x, and we have negative 5 equals 0. So it is easily that we find that A here equals 4, B here equals negative 4, and C is negative 5. Yes, there is x here, don't forget. And we try to find out discriminant. B power 2 minus 4ac equals what? B power 2 here means 16 minus 4 multiply A, which is 4, multiplied by C, which is negative 5, and we will have the answer here. We have 16 minus 16 here, negative 4 times negative 5 here equal 20. 20 times 4, try to calculate mentally. 4 times 20 equals 80. And of course we have negative number. Why? Because negative 80 more than positive 16. If we try to find out the answer, 6 from 10 equals 4, and 1 from 7 equals 6. So it is negative 64. It's less than 0 or negative number. So the two discriminant will be two complex roots. Okay, let's move to another question. Yes, my dear students, if we have a question have a denominator of x or any other number, I think most of students have a problem with it. So try it now. Determine the two roots of the equation. 1 plus 2 over x equals 5 over x power 2, and take care kx doesn't equal 0. You do nothing with this. Just x doesn't equal 0 because we cannot put 0 here in the denominator. We have the equation. When we have the equation, it's not like a formula, and it's a problem for some students. But you intelligent students, you will have a solution for it. We have here x power 2 and x and over 1. If you want to remove this x power 2 and x from the denominator, you have to multiply by all the equation by x power 2. Multiply all the equation by x power 2. Why? Because if we have x power 2 here times 1, the answer will be x power 2. And x power 2 multiplied by 2 over x here, x will cancel with 1x from numerator, and we multiply 2 by x equal to x here, equal x power 2 here cancelled with x power 2, the answer will be 5. So this equation here is simplest more than the first one, but we must transfer 5 into the left side. We have here x power 2 plus 2x minus 5 equals 0. And we know that a here equals 1. Yes, we have here a equals 1, b equals 2, and c equals negative 5. and we will calculate discriminant, which is b power 2 minus 4 is c equals b power 2 here 4 minus 4 multiplied by a, which is 1, multiplied by c, which is negative 5, and the final answer will be 4 plus 4 plus 20. The final answer will be 24, which is positive number. And if we have here a positive number, we know that this equation has two different real roots. Okay? Yes, my dear students, I am very happy to meet you today, and wait us next Friday, inshallah, to give you some geometrical lessons. Goodbye and good luck.